गुड मॉर्निंग स्टूडेंट्स, कैसे हो? आई होप आप सब लोग सेफ होंगे एंड also keeping yourself safe from the coronavirus. In today's topic, we are going to discuss the sphere, one of the three-dimensional shape that we are going to study under the unit number 5, that is solid geometry. So pay attention here guys and let us start. Today we are going to discuss about the tangent plane of the sphere. As an example, जैसे हम किसी फुटबॉल पर या तो बास्केटबॉल पर अगर अपनी नोटबुक प्लेस करें तो जिस तरह का शेप, जिस तरह की फिगर बनेगी, दैट इज़ नथिंग बट द टेंजेंट प्लेन टू द स्फीयर, एंड इट इज़ ऑल्सो शोन टू द राइट हैंड साइड टॉप कॉर्नर ऑफ दिस स्लाइड. सो इफ वी वांट टू find out the equation of that tangent plane for the given equation of a sphere, then how to find it out? So suppose we have considered an equation of a sphere as x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. Then the equation of a tangent plane to this sphere at a point P of x1, y1, z1 is given by x(x1) plus y(y1) plus z(z1) plus u into bracket x plus x1 plus v into bracket y plus y1 plus w into bracket z plus z1 plus d equal to 0. Now how to remember this equation? If we observe both the equation of a sphere and the equation of a tangent plane given in a slide, then you can observe some sort of a similarity in both the equations. जैसे कि if we replace x square, y square, z square in the equation of a sphere by x(x1), y(y1), z(z1) respectively, and 2x, 2y, 2z in the equation of a sphere by x plus x1, y plus y1 and z plus z1 respectively, then easily we can write the equation of a tangent plane to the given sphere. So in this way we can remember the equation of a tangent plane. Now here we have few more important things about tangent plane. The first one is the tangent plane property. If a plane is tangential to the sphere, then the length of perpendicular from the center of a sphere to the plane is exactly equal to the radius of a sphere, and it has been shown in the following figure. You can see it from that figure. And another thing is that if we want to find out the point of contact of the tangent plane and the sphere, then find the point of intersection of the perpendicular line from the center of the sphere to the tangent plane, as the line CP is shown in the figure. Now let us see some examples based on this concept. So first basic example, find the equation of a tangent plane of the sphere 3x square plus y square plus z square minus 2x minus 3y minus 4z minus 22 equal to 0 at the point 1, 2, 3. Find also the equation of normal to the sphere at 1, 2, 3. So solution to this problem, the equation of a tangent plane at the point 1, 2, 3 is given by 3x into bracket x1, that is 1, plus 3y into bracket y1, that is 2, plus 3z into bracket z1, that is 3, minus 1 into x plus x1, that is 1, minus 3 by 2 into y plus y1, that is 2, minus 2 into z plus z1, that is 3, minus 22 equal to 0. And finally, when we solve this equation, we are getting 4x plus 9y plus 14z minus 64 equal to 0. Now the DRS of the normal to the plane are 4, 9 and 14. That is nothing but those are nothing but the coefficients of x, y and z in the equation of a plane, and we have seen in our lecture number 1 about this. And therefore the equation of normal to the sphere at 1, 2, 3, that is the line through the point 1, 2, 3 and perpendicular to the tangent plane, is given by x minus x1 upon a equal to y minus y1 upon b equal to z minus z1 upon c, and that gives us the equation as x minus 1 upon 4 equal to y minus 2 upon 9 equal to z minus 3 upon 14. That gives us the required equation of normal to the sphere. Now example number 2. Show that the sphere x square plus y square plus z square plus 2x minus 4y minus 2z minus 3 equal to 0 touches the plane 2x minus 2y minus z plus 16 equal to 0, and also find the point of contact. Now solution to this problem. If we want to show the given sphere is touching the plane, then we simply have to show, as we have already discussed in the theory part, that the length of the perpendicular to the plane from the center of the sphere is exactly equal to the radius of the sphere. And for that one, from the given sphere, CP, according to the given figure, CP is equal to the radius, which can be evaluated with the formula under root of u square plus v square plus w square minus t, which gives us exactly equal to 3. Now length of perpendicular from the center minus 1 to 1, which is the center of a sphere, on the plane is equal to modulus of 2 into bracket minus 1 minus 2 into bracket 2 minus 1 into bracket 1 plus 16 upon under root of a square plus b square plus c square. Those are the coefficients of x, y, z in an equation of a plane. That gives us exactly equal to 3 again, which is nothing but the radius of the sphere, and which shows that the given plane touches the sphere. This completes our first part. Now let us see how to find out the point of contact. So to find it, consider the equation of a line CP passing through minus 1 to 1 and whose DRS are 2, minus 2, minus 1, which are nothing but the coefficients of x, y, z from the equation of a plane. And that gives us the equation of a line segment CP as x plus 1 upon 2 equal to y minus 2 upon minus 2 equal to z minus 1 upon minus 1. So consider all these ratios are equal to some parameter k. So this gives us x is equal to 2k minus 1, y equal to 2 minus 2k, and z is equal to 1 minus k, which shows the any random point on the line segment CP. So if these x, y, z represents any random point on a line segment CP, then they must satisfy the equation of a plane also, as P is the line point on the plane as well as on a line segment CP. And therefore if we use x, y, z in terms of k in an equation of a plane as 2 into bracket 2k minus 1 minus 2 into bracket 2 minus 2k minus 1 into bracket 1 minus k plus 16 equal to 0, and when we solve this we'll get k equal to minus 1. You can simply check it how we are getting k equal to minus 1. And after getting this k equal to minus 1, if we put it in x, y, z, we'll get the point of contact as minus 3, 4, 2. This completes the solution of this example. Now let us see the next example. Show that the plane 4x minus 3y plus 6z minus 35 equal to 0 is tangential to the sphere x square plus y square plus z square minus y minus 2z minus 14 equal to 0, and also find the point of contact. Here also we have to apply the same method that we have adopted in the previous example. That means first upon we have to find out the radius of the sphere, and we have to show the length of perpendicular from the center of the sphere to the plane is exactly equal to the radius of the sphere. So let us find out the center of the sphere. As you can see, the center of the sphere is 0, 1 by 2 and 1, which can be easily find out from the equation of sphere, and radius is equal to, with the help of simple calculation we are getting it as under root 61 divided by 2. So let us find out the length CP, that is length of perpendicular from 0, 1 by 2 1 on the plane, and that is equal to mod of 4 into bracket 0 minus 3 into bracket 1 by 2 plus 6 into bracket 1 minus 35 upon under root 16 plus 9 plus 36, which is equal to under root 16 divided by 2, which is also exactly equal to the radius of the sphere, and hence we can say the given plane is tangential to the sphere. Now to find the point of contact, again apply the same concept, that is, consider the equation of line CP from the point 0 1 by 2 1 and whose DRS are the coefficients of x, y, z in the equation of a plane, that is 4 minus 3 6, and the equation is given by x minus 0 divided by 4 equal to y minus 1 by 2 divided by minus 3 equal to z minus 1 divided by 6 equal to, suppose, some parameter k, and then value of x will be equal to 4k, y equal to minus 3k plus 1 by 2, z is equal to 6k plus 1, which will represent any random point on that line segment CP. If it is a random point, then that point may be P, which is nothing but the point of contact of lines given sphere and the plane, and if it lies on the plane, then it must satisfy the equation of the plane, and hence if we put the values of x, y, z in terms of k in an equation of plane, then by simple calculation we are getting k is equal to 1 by 2, and after putting k is equal to 1 by 2 in x, y, z, we are getting the point of contact as 2 minus 1 4, which completes the solution of this example. One more similar type of example we have here, that is, show that the plane 2x minus 2y plus z plus 12 equal to 0 touches the sphere x square plus y square plus z square minus 2x minus 4y plus 2z minus 3 equal to 0, and also find the point of contact. Remember guys, these types of examples are very much important in view of theory examination, and you can see that these types of examples are repeated so many times in the university examination. Here also you can show the first part by showing the radius of the sphere is exactly equal to the length of the perpendicular from the center C 1 2 minus 1 is on the plane, that is CP, and both are exactly equal to 3, and hence the given plane touches the sphere. Now to find the point of contact, again consider the line CP whose DRS are nothing but the coefficients of the x, y, z in the equation of plane 2 minus 2 1 and passing through the center of the sphere 1 2 minus 1, and after finding out values of x, y, z in terms of parameter, as P is the point of contact which lies on the plane, put x, y, z in the equation of a plane, you will get k is equal to minus 1, and putting k equal to minus 1 in the values of x, y, z in terms of k, you will get your required point of contact, that is minus 1 4 minus 2. Guys, let me clear you one more thing. As P is the point of contact, it lies on the equation of a sphere also. So the alternate method is to find out the point of contact, that we can put the values of x, y, z in terms of k in equation of a sphere also, and if we solve them, then also we'll get the corresponding value of k, using which we can find out values of x, y, z, that is the point of contact. But it is more difficult to put the values of x, y, z in equation of a sphere and to get a value of k than the putting a value of x, y, z in equation of a plane. As an alternate method, you can try it at least once in any particular example, you will see the difference. Now let us see second type of examples. Find the equation of a sphere which passes through the point -1, 0, 0 and touches the plane 2x minus y minus 2z minus 4 equal to 0 at a point 1, 2, minus 2. So here we don't have to show, guys, the plane is tangential to the sphere. Rather, we have to find out the equation of a sphere which is touching to the given plane at a particular point. So the point of contact is also given to us. So I have drawn a figure over here where you can see P is the point of contact, its coordinates are given to us. We have given one more point Q, which is a random point on the sphere. Our sphere must pass through that particular point, -1, 0, 0. So solution to this example, according to the figure and from given data, the equation of line CP, which must be the normal to the given plane, can be written as x minus 1 upon 2 equal to y minus 2 upon minus 1 equal to z plus 2 upon minus 2, where the 1, 2, minus 2 are nothing but the point, one of the point on that line segment CP, and 2, minus 1, minus 2 are the coefficients of x, y, z in equation of plane, which represents the DRS of that normal to the plane. And suppose that equation of line CP is equal to some parameter k, so that we'll get the corresponding values of x, y, z in terms of k as 2k plus 1, 2 minus k and minus 2 minus 2k respectively. If it represents any random point on a line segment CP, then it may represent C also. So let us consider the coordinates of C are 2k plus 1, 2 minus k and minus 2 minus 2k. Then from figure we can say Cp square is equal to, according to distance formula, 2k plus 1 minus 1 whole square, that gives us 4k square, plus 2 minus k plus 2 whole square, that gives us k square, plus minus 2 minus 2k minus 2 whole square, that gives us 4k square. So total is equal to 9k square. So value of Cp square according to distance formula is equal to 9k square. And Cq square, that must be again a radius where coordinates of C are known to us and the Q are also known to us. So according to distance formula, Cq square is equal to 2k plus 2 whole square plus 2 minus k whole square plus minus 2 minus 2k whole square. But from figure, Cp square equal to Cq square. So when we equate both these values and simplify it for the value of k, at the end we are getting k is equal to minus 1. With the simple calculation, guys, you can easily verify this. I'm just skipping that calculation due to time constraint. After getting this value of k, putting this value of k in values of x, y, z or coordinates of point C, will get the center of the sphere, that is -1, 3, 0, and putting that value of k in a Cp square, we are getting radius of the sphere is equal to 3. So applying the center radius formula for the sphere, equation of a sphere, we are getting x plus 1 whole square plus y minus 3 whole square plus z minus 0 whole square is equal to 9. That gives us x square plus y square plus z square plus 2x minus 6y plus 1 equal to 0 as the required equation of a sphere. Let us see one more example of same type, where the equation of tangential plane is given to us and a point of contact is also given to us, and we have to find out the equation of a sphere passing through a point 1, 1, minus 3. So to find values of x, y, z in terms of k, first upon consider the equation of a line segment CP, which passing through the point of contact P 3 minus 1 minus 1 and having direction ratios as the coefficients of x, y, z in a given plane. So it gives us x minus 3 upon 1 equal to y plus 1 upon minus 2 equal to z plus 1 upon minus 2 equal to k. Suppose some parameter. So we'll get values of x, y, z in terms of k. And these values of x, y, z again will represent any random point on a line segment CP. So if it is a point C, that is the center of the sphere, then according to the figure, Cp square and the distance formula, Cp square is equal to, again we'll get k square plus 4k square plus 4k square is equal to 9k square. And from figure, Cq square, which must be radius again, is equal to, using distance formula, k plus 2 whole square minus 2k minus 2 whole square plus minus 2k plus 2 whole square. And when we equate Cp square equal to Cq square and simplify the equation, we are getting k is equal to minus 3. After getting k equal to minus 3, again put the value of k in x, y, z, will get the center of the sphere as 0, 5, 5 and radius r is equal to 9. And then again apply the center radius formula for the equation of a sphere, which gives us the equation as x square plus y square plus z square minus 10y minus 10z minus 31 equal to 0. I hope students all you are getting the solution of this example. Now let us see third type of example. Find the equation of tangent planes to the sphere x square plus y square plus z square plus 6x minus 2z plus 1 equal to 0, which passes through the lines x plus z equal to 16 and 2y minus 3z plus 30 equal to 0. Friends, together these two lines will give us the equation of a plane. Okay. So solution for this one. From the given equation of a sphere, we can easily find out the center as minus 3, 0, 1 and radius is equal to r with the corresponding center and radius formulae. Then now consider the required equation of the plane as the u1 plus lambda u2 is equal to 0, where u1 and u2 are the given corresponding lines segments. So therefore that gives us x plus z minus 16 plus lambda into second line 2y minus 3z plus 30 equal to 0. When we simplify it, we'll get the coefficients of x, y, z and the constant term as given in equation number 1. Now if the given plane is tangential to our sphere, then the length of perpendicular from the center of that sphere to the plane must be equal to the radius of the sphere, and hence applying the length of perpendicular formula from the center of the sphere to the equation of a plane from equation number 1, we are getting modulus of minus 3 plus 0 plus 1 minus 3 lambda plus minus 16 plus 30 lambda divided by under root 1 plus 4 lambda square plus 1 minus 3 lambda square is equal to 3. That is the radius of the sphere. After simplifying that one, we are getting the equation as 9 into bracket 3 lambda minus 2 whole square is equal to 9 into bracket 13 lambda square minus 6 lambda plus 2. So both side 9 will get cancelled, and after further simplification we are getting a quadratic equation whose roots are nothing but lambda equal to 1 and 1 by 2. Now using these values of lambda 1 by 1 in equation number 1, we get two equations of tangent planes as x plus 2y minus 2z plus 14 equal to 0 and 2x plus 2y minus z minus 2 equal to 0 are the required equation of our tangent planes. Now here we have the last example of this session. A similar third type of example. Find the equation of a tangent plane to the given sphere which passes through the line x plus y equal to 6 and x minus 2z is equal to 3. Guys, again consider the equation of a plane as u1 plus lambda u2 equal to 0, which gives us the equation of a plane in terms of the parameter lambda as 1 plus lambda x plus y minus 2 lambda z minus 6 plus 3 lambda equal to 0, which is given as equation number 1. Now from given equation of a sphere, let us find out the center, which is nothing but 0 0 0, and radius of the sphere is equal to 3. And again apply the concept of length of perpendicular from the center to the tangent plane. Using the modulus formula, we are getting minus modulus of minus 6 minus 3 lambda upon under root of 1 plus lambda square plus 1 plus 4 lambda square is exactly equal to 3. After simplification, we are getting lambda is equal to 1 minus 1 by 2. Guys, you can easily cross verify the value of lambda, and after putting the value of lambda 1 and minus 2 1 by 1 in equation number 1, we are getting two required equation of tangent planes as 2x plus y minus 2z plus equal to 9 and 2x plus 2y plus 2z is equal to 9. This completes the solution of this last example. Guys, I hope I clear all your concepts and the examples which has been included in this topic. If you have any doubt in any particular example, listen this video repetitively and try to clear your doubts. And after clearing all the doubts, try to solve the examples, extra examples which will be given you as a sort of assignment. Okay. Thank you very much. Have a good day.